Hello students, today we'll see how to solve sums from practice set 1.3 of first chapter maths from standard 8, that is rational and irrational numbers. Now let's look at the question here. Write the following rational numbers in decimal form. So here some rational numbers are given and we have to change them into decimal form. So let's look at some of the examples just above the exercise from which we can learn how to convert them. Decimal representation of rational numbers. Now decimal representation means decimal form. Let's look at the example on the third line. 7 by 4. When you divide it, you get 1.75 as the answer. So 1.75 is its decimal form or decimal representation. And when you divide this, also you get a remainder 0. Means after certain division, the number stops. Now let's look at some examples where the division doesn't end. For example, the first sum here, 7 by 6. So if you divide 7 by 6 to get its decimal form, you will get the answer 1.1666 dot 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 and so on. Here this number 6 doesn't stop or doesn't end. So it is a non-terminating number because it will never end. And such numbers we write with a dot or a bar on top of the numbers that are repeating. For example, here 1.6, we'll write here 1.6 dot or 1.6 bar. Bar usually is written when you have two or more numbers that are repeating. Now let's look at the second example, 5 by 6. If you divide 5 by 6, 0.8333 dot 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 is the answer. Here number 3 is repeating. So we write number 3 with a dot on top. Now let's look at another example, fourth sum, 22 divided by 7. When you divide 22 by 7, you get 3.142857 and this number repeats itself. Therefore, we put a bar on top indicating that these numbers are repeating. This set of numbers are repeating. Now let's look at the fifth sum, 23 upon 99. Here 2, 3 is a set which is repeating itself. So we'll write 2, 3 with a bar on top. So answer is 0.23 bar. These are all the decimal representations or decimal form of their respective rational numbers. After looking at some of the examples, let's solve some sums from practice set 1.3. I'll be solving the first sum, 9 by 37. Let's divide 9 by 37 to get a decimal number that will represent it. While doing the division, remember that we are dividing 9 by 37 and not 37 by 9. Now let's start with the division. We know that 9 is smaller than 37. So it is not an actual multiple of 37. So therefore we'll take 37 into 0 and 9 minus 0 will give us remainder 9. Now we'll have to continue the division, and to continue we'll have to take the zeros after decimal number in the dividend. And to take the 0 down, first we'll have to put a decimal number in the quotient. After putting the decimal number in the quotient, we'll take the 0 down and the number will become 90. Now I will have to find out a multiple of 37 which can be subtracted from 90. So 37 2s I know is 74. Therefore I'll take 37 into 2, that is 74, and when I subtract, the remainder is 16. I'll bring another 0 down and that will make the remainder 16 as 160. Now I will have to find a suitable number that can be subtracted from 160. So 37 into 4 I know is 148, which can be subtracted from 160. So therefore I'll write down 37 4s are 148 and subtract it from 160, which will give me 12. Again I'll bring another 0 down, which will make the remainder 120, and I will continue the division. Now 37 3s is 111, so I'll take that number here, 37 3s are 111. That will give me the remainder 9. This is the same number that we started the division with. So again, when we go on doing the division, it is going to be the same steps that we have done earlier. In the quotient, the same numbers have started to repeat. That means the number is going to continue with these three numbers repeating, 2 4 3 2 4 3 and so on. So therefore this number is recurring and non-terminating. So I'll be writing 0.243 bar on top. So this is the answer. You can stop dividing as soon as you can see a number repeating in the quotient. So for example, here 2 is the first number that repeats itself. So after that you can stop doing the division, and you don't have to go further. Let's do the fourth sum from the exercise. So it is minus 103 by 5. So let's first divide 103 by 5. We know 5 twos is 10. So here we get 0. Bring 3 down. Now 3 is a number which is not a multiple of 5. So we'll take a point in the quotient and bring 1 0 down, so it becomes 30. Now 5 6 are 30. Subtracting, we get answer 0. So the division stops here because the remainder comes as 0. So the decimal representation of this number is 2.6. Now since it is minus 103 by 5, the answer to this number will be minus 2.6. And remember, since it is a terminating number, there won't be any bar on top of the number. Similarly, you can do all the remaining sums from practice set 1.3.